Okay, this video is going to serve two purposes. The first of which is to kind of overview the actual assignment that is going to be due next week. Right now the due date's going to be next Thursday. This may get changed depending on how much difficulty we have in the next part of this video. Anyway, so the goal of this whole entire assignment is to design a 4-bar mechanism that's actually a true application. In this case, it's like the gripper for a robotic arm. Now the 4-bar linkage you're going to design, there's actually going to be two, but I mean they're symmetric, they're a mirror opposite of each other. So if you design one, the opposite is just going to be the reverse. Like this connector link is the same as this one, and so vice versa. But essentially, you have this gripper arm that's supposed to be the coupler, which is between these two connection points. It needs to move from this position to this position. What that'll do is when they're both moved into these inner positions, the two grips will actually be against each other more or less. I don't have it perfect, but this is just a practice anyway. So the two left position lines are for the left grip and the two right are for the right grip, and so on. So the whole entire goal, since you're going to be connecting these connectors straight to the coupler itself, is to isolate the fixed pivot locations on this base plate in a way that when you assemble this and manipulate the assembly, these two will pass through these two positions. So that's just an overview of the homework. So what is going to be provided to you, or at least what I provided to you as a Creo file, is this base plate and the positions already in the assembly. And then I also provide the gripper, each arm. So you should be able to go ahead and assemble this in Creo. But if you're not in Creo, I did provide drawings for all of these parts so you can replicate them in your respective CAD software that is your preference. But if you're having trouble with Creo running on your computer, if you don't have a regular CAD software to run on your computer, there is another option that's free and it runs in a web browser, so you don't even need to install anything on your computer, and it's called OnShape. Now, the way that OnShape works is kind of at least assembly-wise, is drastically different than Creo or any other CAD software that I worked with. You don't actually assemble parts with respect to reference planes, but I'll get that in a minute. So this is going to be a kind of a learning video for myself as well. I've already played with it a little bit, so I'm kind of familiar with how it works. But what you need to do is go to onshape.com, create an account. You'll be allowed to create a educational account. You just type in your school information, and then it'll send you an email to activate your account, create your password, save it. And then once all that's done, it's going to bring you to a window similar to this. I already have a project that I've started on, which is for this assignment as well. But you won't have anything here. To create a new assembly, anything, they call these things documents. So you create a document. I'm going to name this example. In this example, we're just going to replicate the 4-bar assembly like I did in those previous videos. So we're going to name this example. What this does is when it opens up, you're going to see these planes, but I would like to look at the bottom here. So a part studio kind of sounds weird, but it's essentially just a part. You can create multiple parts within it and whatnot. So it's essentially just a studio where you create all your parts. And then the assembly is what you believe it is assembly. And then we'll get into the assembly part in a minute. But first, let's just start with a generic part we're going to do. Let's just design a single coupler. And if we look here, our coupler is, right now it's a two-piece that would be connected through these grips, but I'm just going to create a link. This is not going to be a perfect example, but the first thing you need to do, it's in Creo, what you could do is you'd click on a plane and then you'd hit extrude, and then it'll allow you to sketch in there. In this software, you actually have to create the sketch first, from what I've been learning, and then you can extrude from a sketch. So the navigation, you can use this box over here to go different planes. You can use these arrows to go back and forth. You can use this drop down menu to get isometric view. You can zoom to fit. zoom to window where you actually draw a window, and then you can do your different shading and hidden lines and whatnot. Other options to maneuver is with your mouse. It's a lot faster for you guys, but the hold, I can't do it. Hold the right click down allows you to rotate around. Let me fix that. Let's get back to our normal view. If you hold the middle click down, your scroll wheel, you can just translate. So hold the right click down to pan or to rotate around, and then just to translate around, you can do the middle click. Zooming in and out, you should be able to use the scroll wheel if you have that option. Because I'm not even using a physical mouse, I can't. So a lot of the extra steps, I'm going to be doing a lot of extra steps that you could probably bypass. But for anyway, so we're going to do a sketch. I want to extrude off the top plane. So we're going to draw a line. It automatically snaps to the datum axes at least, which is kind of nice. To get done, you hit escape, and then in Creo, it would already prompt you for dimensions. Here, you have to use the dimension tool here, where the first time you click, it just creates a line. Let's make this a 3-inch coupler, and then let's split the difference. Come on, escape, dimension. See, this is like a learning curve for everyone. The dimension cannot be added between a curve and one of its points. All right, let's try this one more time. Oh, look at that. I was clicking on the line. No wonder it was going 0. All right, so let's split the difference, 1.5. It doesn't really matter, but I probably didn't need to draw this line. So let's do some circles to do our ends. And another thing with this software being so simple is it doesn't snap to other sizes. So we get to dimension these circles now. All right, so let's just do 0.5 for the heck of it. We're just getting familiar with the software anyway. And then we want to connect the top of these to each other. Escape. All right. All right, and then we want to get rid of these middle things, so we don't need this line anymore. And then to make this one solid part, we're going to use this trim tool, which is just like this delete segment in Creo. And then so that we can create our little pinholes, or the holes that it'll rotate through. Let's go ahead and do that. And then we need to dimension these. I'm just going to say 0.25 because it's half of it. 0.25. So this entire day for me has been trying to figure out a free open source CAD software for you guys to use. When you're done with your sketch and you're happy with it, you hit this little green check mark. I like to go back to isometric just so you can see the sketch. And then to extrude, you just click on the sketch and you go up here to this extrude button. It automatically extrudes in the normal direction to the plane. Let's make this 0.25. Is that gonna be too thin? Nah, screw it, who cares, it's not even important. And then if you, this just blind means it's going straight off the plane. If you want it symmetric about the plane, you can do that as well. And then you have other options, up to next, up to face, which if you have a complex geometry, that'd be fine. I don't know why it's trying to auto type in Chrome, that's why. Anyway, so that's our extrude and that's our part. Here is where you're gonna wanna name the part when you get to the assembly. This is the name that'll show up in the assembly. So we're just gonna call this coupler. That'll be that. All right, so the next thing we wanna do is, I always forget this, so I totally forgot this step. So now we have our coupler. The distance between each axis is 3 inches. So what I'm going to do now, because this is Part Studio, you don't actually have to create new Part Studios to create new parts. You can just create all your parts in this one little thing. So I'm going to create a sketch kind of away from this, just you'll see in a minute why I'm just creating a sketch here, but this is going to be our 2 position constraints. All right, so let's go to top. I probably should have already had this stuff done for you, but I wanted to show you everything. All right, so screw it. Let's just do position like this. And then let's dimension this. 3. And let's dimension to... Oh, why are you doing this, you stupid... Wait, there you are. That's what I was looking for. Like I said, this is a learning process for both myself and you. Okay, what? Oh, it had to load. I guess that's the downside of building this in actual in a browser. All right, so there's the first line, and let's just. Oh, come on, my auto clicks are a piece of shit. Pardon my language in this video. It's not made for kids. All right, so let's say this is our next position. Let's dimension this guy to 3 again. And then we want to do an angle off of this. Let's rotate 20 degrees because, no, that's not, well, who cares, it's 20 degrees, it's just an example. And then let's make this 1.5. I like even numbers if you couldn't tell. And then we're gonna do zoom to fit. All right, so boom. That's our sketch. Lovely. So let me go to the assembly tab down here. And then in the assembly tab, all I'm going to do first is insert the sketch. So you go to insert in your part studio. What you want to do is check sketch and then click the sketch that you want to add. Because you're not actually going to assemble to any datum planes, what you need to do is you need to create whatever your foundational part is going to be. Is you want to click on it and then you click, well, crap, you don't click on anything. You have to right click on your part. It's going to be like your foundation. Everything is going to be based off of this. And for now, it's just the 2 positions. So let's say fix. What this does is it fixes it in place. You can't pull it around. I'm sure there are better ways to assemble this because you do have an origin you can assemble to or around. But for all intents and purposes, this is just to help you get the assignment done. And hopefully we can move away from OnShape eventually. But all right, so we've put our sketch into this, but the one thing I don't like about this is you have to go back to the part studio if you want to do the next couple steps. So let's just go to part studio. What I'm going to do is I'm actually going to edit this sketch because I'm not actually, hold on, screw it. Let's just see if this works. I'm going to create a new sketch. Ooh, I can actually reference this. Maybe, I don't know. All right, so the first thing we want to do is locate our pole. Oh, sweet. This is actually nice, this sketch. So we're going to create we're going to connect. Come on. I clicked on the line. We're going to connect these. Now we're going to see how well this, actually, before I do that, what's this thing? Looks like, oh, never mind. All right. So now we want to find our poles. Good. Oh, look at that. It automatically snaps to perpendicular. That's so nice. It's nice when a new software does what you hope it does. It means that people that designed it were, no. All right. You guys could probably be a little bit more elegant than I can be at this. So I know I didn't make this long enough. I never do. But instead of that, we're going to do this one because it's a better angle. I don't want to zoom out. I don't even know how to zoom out. All right, hopefully that's enough. Beautiful, look at that. We have now located our pole. All right, so now that we know where our pole is, and we're just because it's going to be along the assignment, we know that these 2 positions are going to be our moving pivots. So that makes our line of moving pivot the line that would connect the pole to these points. and which means these perpendicular bisectors are now our line of fixed pivot. Now, we can make the decision now because we're arbitrarily making an example, but and because I'm lazy, I don't want to make this video too long, I'm just going to say, boom, let's go horizontally, boom. These two positions are going to be our, our fixed pivot locations, which means our connectors are going to be these two lines. So just kind of review what I just did. Our two position constraints are here. I know this part's kind of in the way. Actually, you know what? I wonder if I can hide that. Wait. Maybe if I can suppress it. Oh. All right. Ignore that part of the video. All right, so let me just recap. We have our two position constraints. To figure out the pole, we connect the two endpoints and then draw lines until they intersect. This is our pole, which essentially means this line is going to rotate to this about this point. And then once you have these and you know that you're going to be connecting directly to the coupler, that already tells you where your moving pivot locations are going to be. And all you need to do is find your fixed pivot. For this example, we're arbitrarily. In the assignment, however, you have a base plate that you have to find where these lines will intersect and where you choose to place them. Like, let me go back here. So you already know this is your material. So you know your fixed pivot locations have to be on this plate somewhere. So that's up to you to decide. That's the fun part of design. And this is just for fun anyway. You're learning a new technique of how to design 4-bar mechanisms. Something I never learned when I was taking this class. All right, so now we know that these are going to be our two connectors, so we want to know what is the dimension or the length of these. We're not going to modify it because these are constrained to our choices. Why is this one not as dark? Oh, I bet you it's because it's... Huh. Interesting. Anyway, because I can't memorize things, I am going to take a little snapshot of these numbers. All right. Beautiful. Now we have those things done. Let me go back to isometric. Let me unsuppress this. We're going to hide you, and we're going to hide you because we don't need. All right, so we need to make one 1.523 and then one 2.437. So let's just make one. So first, we're going to have to pretty much do the same thing we did here. So the top datum plane, we're going to sketch. I'm going to try this in a different way to make this a little bit faster. I'm just going to, there's two circles. And then two inner circles for the pin. All right. And then let's dimension some of these. So 0.5, you don't need to type 0 first. 0.5. 0.25. 0.25. Now I should have done this on a line because I know these aren't going to be the same. So let's do this first, the small one first. 1.523. 1.523. I bet you can actually reference these sketches, which I should have done. I don't know why I didn't do that. All right, and then we want to make. No, that's not what I wanted. Stupid piece of shit. All right. Ah, son of a biscuit. Go away. Boom. We want this to be 0 because we want them on a plane. Awesome. All right. I'm not sure how to do tangent lines. Oh, that don't work. So that's why I want these to be in a plane, because I know they have to be connected somehow. Wait a second. That did not do what I wanted to do. All right. You guys will probably have a better time with this, but my clicking mechanism is not as easy. So I'm zooming the hell in with this. So we want to attach there. We want to attach there. Oh, why does it do it? Oh my god. All right. So then we trim the inside, and we have a part. Let's go back to here. You know what? In this sketch, I'm going to draw the other part as well. Why not? Let's be adventurous. All right, so screw it. I'm doing this. I'm using these planes because I am lazy. Actually, I'm sick of working on CAD software. I don't enjoy. All right, 0.5, 0.5. This is a mess. By no means is this the way I wanted to do this. But I literally just learned how to use this software with like 20 minutes before recording this. All right. I want you to be 2.437. 2.437. Oh shit. One. Let's get these things away from each other. Zoom to fit. Zoom to window. Let's zoom in our points of interest. All right, so let's connect these. Same way we did this. I have no idea if this is going to work or I'm wasting your time, but we're about to find out. Matter of fact, if you want, you can fast forward and see if I was successful or not. Actually, make your guess in the comments below. Was I successful in this? Help me help my channel get noticed. All right, so the moment of truth. Holy cow, it worked. That's awesome. Awesome. All right, 0.25. Oh, that is so nice. All right, part 1. This is going to be connector 1. Let's rename you. Connector 1. You know what I just noticed? Or realized? Oh, come on. You don't even have to hold control and you can like highlight every item. It's so stupid. All right. Rename. And I just realized how to hide parts. See, we're both learning. We're learning this together. Did I just name that connector 1 as well? And that's why I didn't put a number next to it. Of course it did. Connector 2. All right, see, I actually found out how you can hide stuff. Boom, it's hidden. Boom, it's unhidden. Look at the magic we're learning today. All right, so we have our 3 parts. We have our coupler, our connector, and our connector. The one thing I didn't do is I didn't. No, I don't want that. I want you. And you should have been in there as well. Of course I did it that way. All right, so let's screw it. All right, so let's go back to our assembly. I did assemble this, but I'm going to delete it because I'm saying screw you. All right, so there's a reason why. All right, so let's insert. I want to insert sketch, not part. You can insert both sketches and parts from Part Studio. It's very happy to assemble as much as you want, but we're gonna bring both of these at the same time. Why? Oh crap! Screw it. Assembly, insertion, cancel. Cool. All right. We are learning how to use this software together, aren't we? I'm going to go ahead and create a base for this because I'm stupid. All right, so that's our, all right, so that'll help. All right, we're going to create a new sketch on the top plane. Sketch. Top. This is going to be our line for our base, so we're going to go ahead and do that. We're going to size these. Let's make this 0.5 as well. Make this 0.5 as well. You know, I'm starting to actually enjoy this CAD software. It's nice. It's in a web browser, so it doesn't take up any space on your computer. It won't kill your computer like Creo can do sometimes. I know some of you can't even open it up on your computer. All right, so in the spirit of making it similar to the example, I have no idea if that's, I wish it, that's one thing I don't like. Come on. All right, there's multiple things I don't like with this software. But I bet you the more I use it, the better I'll get at it. All right, so let's snip. Oh, it's loading. Spin and spin faster. Hopefully the internet doesn't kill out. What is that? Go away. All right. Oh, the whole freaking line went away. Anyway. Oh, why did I even do that? I'm stupid. Look at that. The snap lines aren't even that great. I am just having fun with this software, I guess. I don't know. If you guys don't want to watch me create this base, just skip ahead. I am determined to figure this out. Actually, I'm just frustrated. All right. All right, so that's that. Seem to fit again. I'm lazy, as you can see. I'll just snip it later. This kind of looks familiar, don't it? It's a little base. Oh, I just want to start singing all about that bass. All about that bass, bass, bass. All right, let's just make. Let's try clicking on the actual. Oh, I wonder if I can do this. Go away. Look at that. Oh my God, we're all learning stuff right on the spot. This is like watching your kid grow up in like the blink of an eye. All right, so that's our base. That's not what I wanted. Let's move this sucker like way away from this. What? Sketch cannot be solved. What did I even do? I wonder will this allow me to. Oh wait, there's already a dimension here. I have no idea what's going on here. All right, screw it. I don't know what's going on. This is so freaking annoying. I'm just gonna figure this out. Copy this number. And then we're gonna completely delete the sketch. We're gonna hide this top, sketch again. All right, if you're just seeing this now, I made a lot of mistakes. So you have the opportunity to skip ahead if you really, really want to. Five. I swear, like it makes 0.5. Oh, I don't even use a plane, so I just want. No, I want dimension. All right, we're gonna paste that number in. Oh, this is a moment of truth. Is this gonna be tangent? Nope. Oh. I was like, oh, we just constrained that. Look at that. All right. Just go away. This is a horrible video. This is not how I intended this video to come out. I apologize for that. 0. Oh, it's kind of close to the number we want. Zooming in. Moral of the story, people. Try and get a professional CAD software like Creo to work. When you're stuck back to doing this, I know this is perfect because anyone and everyone has access to it, but I am not proficient at this at all. I am barely familiar with it. Creo I've been working with for, Jesus, almost 8 years now. So my skills here kind of suck. But you're watching me learn how to this, and hopefully if you guys have to use this software, it goes a little bit better than you. I know this is not like a base looking thing, but I know I can create these parts. So, isometric, sketch, extrude. Just so everyone knows, this is the base. I'm just gonna make it 1 inch. Look at that. Lovely. All right, so this is going to be the base. I'm going to rename it as the base. Oh, come on. Oh, Jesus. All right, well, we're going to have to learn something. There's a reason I was creating it over there. Now I know why, because it was in line with the sketch. All right, screw it. Let's just go to assembly. Did that work the way I wanted it to? I hope so. I don't know. I have no idea if this is work. We're going to figure it out as we go. All right, these are fixed. Now, do you think I can assemble the base to be along this line? I doubt it, but let's try. All right, so now we're going to play with this assembly thing. We're all going to learn. All right, so first thing I'm going to do is see if I can plane. This is a plane, so we're going to do fasten. So if I was to look at the front view, yay, that did what I wanted to do. Now the question is, how do we get these holes lined up? All right, that's how we wanted that. All right, so the cool thing is now I can drag this guy around, and it can only I swear it moved. Maybe I'm just imagining things, but this did move earlier. Oh, that's because I fastened it. See? Don't do what I do and just on it. Delete. We don't want to fasten it. We want to plane it. Nope. Nope, 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 nope. Zoom to window. Plane. It means we're gonna match planes. Yay! So now this can move around. We want to kind of get something like that. But for now, I'm going to. All right. Go away. Planar 2, go away. All right. So there are some rotational ones. Let's see what. We got a ball mate. We got a pin slot mate. We have a cylindrical mate. Ooh, I wonder if I could do this. I'm just curious. So we're gonna connect. Oh my gosh, that was so cool. Look at that. We are awesome. We're awesome. We did this together. You helped me. Just knowing you're watching me doing this right now, that was amazing. All right. So now we have our base fastened, and I'm going to hide the sketches so that we can start assembling our mechanism to see if this actually works. So we want to. So let's insert. We want a part. We're going to do connector 1. Now the beautiful thing, actually, you know what? Let's just get everything in here. We're going to need connector 2, and we're going to need the coupler. So let's move you over here, move you over here. That should be fine. Seem to fit. Let's go to isometric just for the hell of it. I'll zoom in again. All right, so we want to connect these guys. All right, so the first thing we want to do, this is so nice, nasty. All right, let's do a plane to this. Now that matches those planes, and we're going to offset it. Our thickness is 0.25 inches. Yay. Go away. All right, so now let's move you away a little bit. All right, so now we have the planes, so we know they're matched. So now we're going to do this. This is a rotation constraint. So click Q. What the heck just happened? I don't know. I don't know. Let's just guess. Why does it look like these are going to conflict with each other? Yeah, that's what I thought. Oh. Why is this so far down to the right? All right, so let's see. I know this is it's a mate. I love it. It's constraint or connection. If I hover. Sorry if I'm not talking. I'm just trying to. Did I just? All right, I have no idea if that just worked, but we're gonna find out. Oh, we are awesome. Thank you for sticking with me this far. All right, we're gonna do the same thing with this other piece. So we're gonna do a plane mate first. We're gonna offset it by 1/4 inch. Do that, go for you. We're gonna move you over here a little bit. We're gonna zoom in so we have full control over what we're clicking on, since I suck at this. We're gonna do this revolute mate again. We're gonna click this. And then you have to offset. Neat. The wrong way, obviously. I wanna go negative, I guess. Please work, please work, please work. Awesome, so now we just gotta connect the last piece to this, and that should be it. All right, so we're gonna do plane again. Boom, boom. All right, so now we're gonna offset this in the negative direction, -1.25. Are you serious? I wanted to go there. All right, go to the bottom, thank you. All right, so if I understand this right, all we have left to do, so we've already connected the plane, and the way these constraints, or mates they call them, have been happening, I think all we have to do is line up this hole to this hole and this hole to this hole. So let's see if we can do that. We're gonna go like you, we're gonna go like you, and we're gonna go like you. What in the hell just happened? We obviously did not do something correct. Let me zoom in and not get click happy. All right, so we want you. That's not what I wanted. Undo. Awesome. All right, so that's what we wanted. Offset 0.25. Is going to go the right direction. No, wait, that is the right direction. Oh, we're almost there. We're almost there. I know this video is long, but honestly, I had to learn this software while you guys watched. So you guys can obviously skip ahead. All right, last one. I wonder, because this allows you to offset, if I didn't even have to do this planar offset. I don't know. I'm not trying to figure out the software really. I just want to get something so you guys can do the assignment. And if everything worked the way it was supposed to, I should be able to move. Oh, look at that. We got a 4-bar mechanism. Now we have our lines. Let's see. Zoom to fit. All right. Now, if everything worked the way it was supposed to, I should be able to. So it does start at this line, and if we go down to here, look at that. We have a winner. We have successfully created our 4-bar mechanism in OnShape CAD, which, in my opinion, is not that bad of a free CAD software. I mean, I think you have to be, I don't know how, if it's free for everyone. I think you have to have it, like, because I had to sign up for an academic license, so you may not have to sign up for an academic license. Who the hell knows? I don't know. I'm new to this. I literally downloaded this like an hour and a half ago. All right, so I know this is a long video. I know a lot of crap went in this video, but this is essentially an overview of the homework assignment, which I'm doing it one more time. See, look how much prettier it is in Creo. Anyway, this is besides the point. All right, so we have our 2 position constraints. We know this is a starting position for our coupler. This is an ending position for the coupler. Our coupler is technically defined as the link between these 2 attachment points. Go away, Glassdoor jobs. You haven't found me a good job yet. And Atrium Health, I know. Stay at home. All right. So technically your coupler is a connection between these 2 points. I mean, the whole thing is one link, but you're only concerned about these 2 connecting points because that's where the connectors are actually going to link up. And they want to pass these 2 points. So I will provide this base as well as the sketch and then on share, I think. Let me figure out if I can actually do this. So I've already created this. Did I actually created the, wait, this is, I'm gonna go here. All right, so this is the main assembly. I've already established this as your base. This is the foundation. You are responsible for finding the holes in which, just a tidbit if you're using the software or anything else, I would do your sketching. So like I said, so for this example, we built all our parts in this one little nice little studio. While I was learning how to use the software, I thought each one of these studios was the individual part, so I kind of broke it up. I created a coupler, and then I created a grip arm assembly, and then in the main assembly, I should name this main assembly, so you have the video, you know what it is. You can insert assemblies. What I'm going to do is I'm going to share this with you. Let's go to OnShape. I'm going to share this, hopefully this share works, with the class. Actually, you know what? I'm going to actually, if you watched, made it this far of the video, if you want to use OnShape and you don't want to use Creo or SolidWorks or NX or CATIA, or you don't have CAD on your computer, you don't want to worry about installing it on your computer because you're worried it won't run as well, and you want to use OnShape, send me an email and I will share this personally with you and coordinate with you to make sure that you get this file and it works the way it's supposed to. But pretty much, I've already created these parts for you. All you really need to do is go into this base. I'm giving you hints. Go into this base, figure out your pull locations, figure out where you want to put your fixed pivot points, modify this geometry, which if you want to modify this to put your holes in, once you know where the holes are going to be, all you have to do is go to the sketch that drew it, and you can make your holes in the places that you want. I'm sure there's a hole option probably right here or somewhere up here that you can just put holes in it, but I haven't gotten that far. If you want to explore that, you can. Anyway, go in here, figure out your pole location, figure out where you want your fixed pivots, and then once you have your fixed pivots, you can draw your connectors, and then you can make your connectors, and then in the main, you can assemble them, and then when you're done, let me know. We'll figure out how to send this back to me. If you are not using OnShape and you're using another CAD software, if you have SolidWorks or Creo, just send me the files. If it's another software, let me know what type of software it is so I can figure out a way of how I'm going to be able to check your assembly and make sure it worked the way it was going to. That's going to end it for this. I hope this didn't go too long. Actually, I know it went too long. I've been recording for almost 50 minutes now, but there's probably 20 minutes of garbage you can skip through or had skipped through. So thank you. Hopefully this is all you need. I am trying to grow this as a YouTube channel with more tutorial videos. So if there's any software that you want to learn how to use, CAD-wise, Simulink, MATLAB, post a comment of what you'd like to see in the future, because along with the lecture content I'm creating for this class, I'm going to continue to create videos on this channel to help out anyone that needs help with different softwares. That's it. Thank you again. Have a good night. Stay safe, stay healthy, and whatnot. Take care.